In this video, we'll be talking about significant figures, why they are used, and the definition of the significant figures. So let's get started with the introduction of significant figures. What's the need for using significant figures? Well, starting off with the introduction, well, you know that uncertainty depends on precise measurements because on precise measurements and uncertainty gives us a limited range of values. So if you haven't watched my previous video, you know that uncertainty looks like this when written in mathematical form. For example, let's say we have a value 1.4 plus minus 0.2 and whatever unit you can use. For example, let's say it's millimeter. So here this plus minus and then the value is basically the uncertainty. 1.4 is the exact true value here. So basically uncertainty tells you the min or and max range, the range of values where the actual value can lie upon. For example, this basically means that my value, if another person were to calculate or run the experiment again, then the values will be between 1.2 and 1.6. So basically 1.4 minus 0.2 will be 1.2 and 1.4 plus 0.2 millimeter will be 1.6 millimeter. So basically saying that even if another person were to calculate anything, calculate that specific experiment or measurements, its answer, its value will lie between 1.2 and 1.6 millimeter. So that was the uncertainty because uncertainty gives us a limited range of values. So that's really helpful in the field of physics because as we all know that errors are inevitable. So therefore we need a set of digits that can show how precise these calculations are. And that's the reason we use significant figures, because significant figures gives us a precise, a reliable values. um, we'll discuss it onwards with the definition of significant figures. So with the introduction, already the answer still isn't not clear. So what are significant figures? So the definition of significant figures goes like this. Significant figures are the number of digits in a value that determine the degree of accuracy and reliability of that value. So the two words that you need to be careful of is the word accuracy and the word reliability. So accuracy meaning how close is to the true value, and reliability that whenever that repeated measurements don't give off a huge gap between values. So let me give you a simple example of it, so this might make it clear for you. For example, we have the digits 4.709. So as I have stated above, there are four significant figures in this value. So this is the one. And let me also tell you that it will be start from left side. So the counting will start from the left side. So 4.709. So there are 1, 2, 3, 4. Four significant figures here. And as I said it before, the definition of it, and as I said, to be careful of accuracy and reliability, we always know that. For example, what if the values are more than this? For example, the values are just continuing. For example, let's say we have another value. It continues on like 4.7 or 9 or 1. Sorry. Okay. I hope you can see it. This I hope you can see the number here because of the color of the background here. So let's say the value is 4.70914. So you can say that the significant figures are 5, 6, and 7. There are 7 significant figures, but it will heavily depend on, as you guessed it, the accuracy and reliability of the value, because we all know that the more the more the values are here, the more values will fluctuate. The more, because we all know that in the real life, no matter how, the two values, repeated values, cannot be the same. As the more you can go on with the least count, the more the values you have, the more less the less precise they will be. So it will depend. So that's the whole reason of significant figures, that the values that are both reliable, that don't cause many fluctuation, they are less fluctuate, don't fluctuate more often, and they are accurate depending on the instrument. So how far you can go with this will heavily depend on the accuracy of that measurement. For example, if the accuracy of the measurement allows it to be for the first three digits after the decimal point, then you will have four significant figures, as your value will have less fluctuations. They will be close to each other. They will be more precise, reliable, and they will be accurate, as you have guessed it. So so uh, I'm sorry, I've gone too much into the detail of this, but I will in the next video I will be talking um, about more about significant figures and the rules, and the rules that you need to be careful of when you are trying to write significant figures. So that this all will be in the next video. So basically the this video is all about significant figures. That's all. We will discuss the rules about it, how to write everything of it in the next videos. So continuing on with the significant figures. So all the numbers from 1 to 9 are considered significant. One, so 1, 2, 3, 4, 5, 6, 7, 8, and 9. So they are considered significant, except the 0 here. Except 0. So 0 may or may not be significant, and this totally depends on the location, the position, in the position of 0 in the numerical value. So based on this, its location, the zero is divided into three types. Basically, it depends on the types which are based on its position in the numerical value. So there are three types of it: leading zero, captive zero, trailing zero. So let's just say, to keep you in mind, basically leading is left, captive is middle, and trailing is right. So basically these left, middle, right are basically the location of the zero. I hope this makes it easier to understand, although the names of these zeros can tell you the whole picture. Okay, let's get started with the leading zero. So leading zeros any come before any other non-digit, and they start at the left of the numerical value. So here they leading zero, as I said, left. So they start at the left of it. They come before any other non-zero digit, which is basically 1 to 9. So lead zeros are not significant, therefore they can be neglected. And these both include decimal and non-decimal values. So here we can say that 0 at the start of it doesn't are not considered significant. Basically, even if you neglect this, you can still basically write this. So there's no need for including these zeros. On the other hand, here we have 0.0014 and decimal point here. The decimal point is here. But I said this includes for both decimal and non-decimal values. So here we can actually say that we can write this whole value in scientific notation. How? So basically I can write it as 1.4 times, so the decimal will point across as 1 2 3, 3 digits, that will be minus 3. So I can basically write it as 1.4 times 10 to the power 3 without including these zeros. So I hope you get the idea. So let's get to the captive zero. So captive zero, as I said in the previous slide, is the middle. So basically saying it, this zero kind of is positioned inside these non-zero digits. So they are not, they are stuck inside of it, they are middle of it, they cannot be on the either left or right of it, they are just in the middle of it, they are inside these non-zero digits. So as for the captive zeros, so captive zeros will always be considered significant no matter what their sequence is, as long as the as long as this one, I will try to explain with this numerical value. As long as the right and left are non-zero digits, they will be considered significant. And also this includes for both decimal and non-decimal values. So here we have the value, as you can see that the zeros are encapsulated inside these non-zero digits, and here the non-zero digits are 1 and 6. The same goes uh, with this value, which is the decimal value. So here the non-zero digits are 1 and 9, which are at right and left. So the significant figures are counted as, there are 5 significant figures here, 1 2 3 4 5, and here we have also 5 significant figures, 1 2 3 4 5. So basically simple, as long as they are inside the non-zero digits, they will all be considered significant no matter what their consequence is. For example, if I have to sneak another zero in it, that will not change it. That will still be counted as a significant figure. So that will become 5, and this will become 6. So as long as they are inside of it, they are considered significant. And then going on with the last one is the trailing zero. So as the recent slide, at the previous slides, I said trailing zero, right? So these trailing zeros are located at the right of it, and they, as said here, they come after non-zero digits located on the right side of the numerical value. And there's a catch for the trailing zeros. So trailing zeros are only considered significant if the numerical value contains a decimal point. So if they are non-decimal, there is no decimal point, they are non-decimal, then they will be neglected. They will be neglected, and if the decimal point is present, they are decimal, then they will be considered significant. So, for example, here we can neglect it because we can also write it as 4 times 3 4 5. We can also write it down as this 3.844, and here we have 4 significant figures. So but in the case of a value that has a decimal point, you have to you have to include those zeros, the trailing zeros, as significant figures. So here, even though they are zeros, they are trailing, they are on the right side of it, but there's a decimal point in it. So that's why we will consider it as significant. So here we have, above it we had 4, here we have 6, 1 2 3 4 5 and 6. And there you have it. That's the end of the video. And in the next video we'll be talking about rules of writing significant figures. As I said, significant figures, there are limited amount of figures that you can have, that depends on the accuracy of an instrument. So if the value is too big and you have to include only a few significant figures, for example, the numerical value has 9 digits, for example, 6 digits, total 6 digits, and you have to, but the accuracy of an instrument allows it to have 3 digits, and it is accurate about to 3 digits, so we need three significant figures. So how will we reduce it down? So um, this is the end of the video. I hope you have liked and enjoyed this video, and I'll see you in the next one. Thank you.